seems blurry. Solubility, maybe because that light's out. Somebody say take a walk, please. Solubility.
I got it.
It's the amount of solute.
How about the distribution of ions within water?
No. The amount of solute that can be dissolved in a certain amount of solvent at a given temperature, right? So what would the unit be on solubility of a ionic solid? Grams per. Good, it's grams per. It's the amount of solute, that's grams, that can be dissolved in a given amount of solvent. Liters or milliliters, right. Grams per liter is what you're going to see. Grams per liter. The temperature will be constant for these questions. So they'll say at a certain temperature. They may not even say the temperature at all, actually. But the amount of solvent is volume, like 100 milliliters of water, right? So 0.1 liters. And then grams of solute. So when we're setting up KSP equations, so let's review that. If I want the KSP of AgCl, how would I write that? What would I write? KSP equals concentration of Ag plus times the concentration of Cl minus, right? And if there was a 2 in front of Ag, what would I do? Square it. I would square that, right? Okay. So when we're gonna solve some problems right now. When you have KSP problems, if they ask you what is the solubility of silver chloride in whatever, however much water, solubility means grams per liter. If they ask for concentration, what's the unit? Moles per liter or molarity. And what's the unit for molarity? Capital M is molarity. What's moles? MOL. Okay, please remember that. What's little m? We never use it in chemistry. Meters. Meters. We could use it, but we're not going to. Okay. All right. So I don't really go on and on and on about solubility. You should kind of already know what that means. If Q is less than K, what type of solution do we have? Unsaturated. So again, if the ion concentrations are less than they should be at equilibrium, that's what Q means. When it's less than K, that's what it means. When the ions concentrations are less than what they should be at equilibrium, we're shifting what does unsaturated mean as far as like an equilibrium in these KSP? You can dissolve more, so you can increase your concentration of ions, which means you can shift to the right. If you're at equilibrium, Q is equal to K. If you have too much dissolved, what's going to happen? It's going to precipitate. So that means you have supersaturated, you shift to the left, which is where the solid is. So I want to say that one more time. So you can look at one of the examples from yesterday. What's the last one we wrote? Was it BaSO4 or was it AgCl?
BaSO4. Yeah, BaSO4.
Okay, so BaSO4 solid's on the left side. So if you have a supersaturated solution, we are shifting to the left. You're going to precipitate. You're shifting left. That's a solid. If you have an unsaturated, you're shifting right, meaning you can dissolve more. You need to get that kind of concept, otherwise it gets confusing. Okay. All right. So I'm going to give you a sample problem here, and we're going to be using ice tables. But the nice thing about the ice tables is we don't need anything for the reactant. So it's just our two ions. So here we go. At 25 degrees Celsius, an equilibrium between undissolved Ag2CrO4 and Ag2CrO4 aqueous is achieved in a flask. So I'm just going to write that. So if you're given this Ag2CrO4 solid in equilibrium with Ag plus and CrO4 minus 2. Now, I'll label AQ this time, but I'm probably going to stop labeling that. You need to know it's aqueous. Just throwing that out there. We need 2 Ag plus. So, after analysis, it is found that the concentration, so again, equilibrium is established. The question said that. I guess I can write that. So equilibrium is established, and the concentration, what did I say? Of silver ions, concentration of Ag plus is equal to 1.3 times 10 to the negative fourth moles per liter. Calculate the value of KSP. So we're gonna start with the two similar type of problems we did with K, P, and KC, where when we first learned about it, I gave you the K value and you solve for concentration, or I give you the concentration, you solve for K. Same exact process, it's just now we're in solutions. So this time, I give you the concentration, you have to solve for K. We'll do another problem where I give you the K, you have to solve for concentration. So that'll be next. So again, set up an ice table, if it helps. Except there's nothing for the reactants. They're solids, they're not in the KSP equation. I would set up an ice table. So can I erase the question so I can use space for a nice table?
Yeah.
What's up, Dylan?
Start with 0.
Just contemplating?
Yeah.
Hi.
Something's going down today. Yeah, something's going
No
down.
react.
You just leave like that.
to kill Matt today with the name
Yeah, you don't actually, you can erase this. Set up a nice table like we always have. So you have ice up down the side, here's your reactants, here's your product. So for your reactants, it's going to be like 3 lines. There's nothing's going to go there. Everything's going to be on this side. Set up your ice table just like we did in the past. If there's only one reactant, only one product, then that's just X. If there's 2 of them, that's 2X. Just like we did in the past. So you have initial, you have change, you have equilibrium. This question is giving you the equilibrium concentration of Ag+. And if you know the mole ratio, then you know the concentration of the other one. Then you plug it in your KSP equation, and if you make a mistake, I know where that mistake's going to be, but maybe you won't make it.
Yeah, for X. Yeah.
That is my mic.
What?
I don't know what's going on there.
That's
That's just how you do it.
That's how I do it.
That's fine.
Oh, and then you find
It's our differences that bring us together.
That's right.
Everybody keeps getting the same answer. I don't know if that's what I have. Let me double check.
So would you get?
Chances are you guys. Oh, okay, I rounded it. If you got 1.09 times 10 to the negative 12, you got it.
Yes.
Okay, here's how we do these. ICE, no one cares about reactants because it's a solid, and again, the reason for that is because there's usually a lot of the solid, so changing this doesn't really affect concentration very much. Okay, I got 1.1 times 10 to the negative 12. Okay, all right, so technically initially that's 0, initially. This is going to be 2x, this is going to be x. Now, if you happen to look in the book, so when I give you homework problems, if you need to go back, I don't know if anyone does this, it's not a bad idea, but if you go back and look at examples in the book, they will use an S. So in my notes, I use S's, and the reason I use S instead of X is to get us thinking about solubility. So questions about solubility, The book just uses S, which stands for solubility. But X and S are both variables. It doesn't matter. You could use whatever letter you want there. But anyways, I'm going to keep the X for now because that's what we've been doing. So this is, obviously we're doing pluses here. I don't need to put it, but we could. Because if you're starting with all of this and it starts to dissociate, you're creating the ion. So these are never going to be negative. They're always going to be positive here. You're not subtracting. So anyways, this is going to be, what's the number? 6? No. 1.3 times 10 to the negative 4. Why? Because it told us that. That's the Ag plus at equilibrium. Is this number half of it or double that? Half, right? Because it's a 1 to 2. So what's half of that? 6. Now, here's the tricky part that some students forget. The KSP equation, and now sometimes on the AP test, they'll have you just write the KSP equation. That's it, and you get a point for that. It's pretty easy. So if you know the reaction, it's pretty, you just write down what it is. Ag plus squared times CrO4 minus 2. There's your KSP equation. I always tell students, write that out, even if the question doesn't ask. Why? You remember to square it. So technically, this number in here, look up here, technically is 2 times whatever x is squared. So just keep that in mind, because the next couple problems, or at least the next, you got to remember that. It's always, you have to double it and then square it. All right? Double it, then square it. So here it gave you the number, so it's okay. But if it's a question where you have to solve for x, remember you're doubling it and then squaring it. So it would be 2x squared. Anyways, that's why I have students write it out so they don't forget to square it. I'm just going to substitute in my concentrations now. 1.3 times 10 to the negative 4 squared times 6.5 times 10 to the negative 5th. And I rounded that to the tenths there. 1.1 times 10 to the negative 12. Questions? All right, I'm going to squeeze one more in here. All right, so we got KSP of CaF2 is 3.9 times 10 to the negative 11. 3.9 times 10 to the negative 11, that's the KSP for CaF2, calcium fluoride. Here's the question. Calculate the solubility of calcium fluoride in grams per liter. So you're given this. So given CaF2 solid, Ca plus 2 plus 2F minus, the question is calculate the solubility. Calculate solubility of CaF2 in grams per liter. They don't always say that. They sometimes will just say calculate the solubility of calcium fluoride. And then they'll put in parentheses the KSP. They won't tell you the units. That's the frustrating part from my position because you could do everything right and add the wrong units. KSP, ice tables are always in concentration, moles per liter. So you have to convert it to grams at the end. So that's the part that's tricky, all right? So you're gonna set up an ice table and you're gonna solve for X. This time I give you the KSP, you're solving for X. So I'm going to let you work for a couple minutes. Bell's probably going to ring, but that's all right. I'm giving you the KSP. This time you're solving. So same as last problem, except this time you're solving for X. Last time you solved for KSP, this time it's the opposite. That's unfortunate. So you got pre-lab and you got to do a little research so you're prepared tomorrow. Don't come in here and be like, I have no idea about anything.
That's okay. More brains.
That's Dylan Miller.